Welcome to tonight's journey into the deep ocean. Please make yourself very comfortable in your warm bed. Close your eyes and let the day fade away. Breathe in slowly and release your daily stress. Tonight, we explore a very special underwater realm. We will visit the lost city hydrothermal field. This is a place of quiet underwater mystery. Your mind can drift safely into the gentle abyss. The ocean holds many secrets in its dark depths. We will uncover them together in peaceful tranquility. Let the rhythm of my voice guide your descent. The surface world is now far behind you. You are completely safe on this deep underwater voyage. Release the tension from your shoulders and neck. Allow your breathing to match the slow ocean currents. We are embarking on a scientific and calming expedition. There is nothing else you need to do tonight. Simply listen and imagine our destination lies within the vast Atlantic Ocean. We are heading directly toward the northern hemisphere. The exact coordinates are 30 degrees 7 minutes north. The western coordinate is 42 degrees 7 minutes west. This location sits far from any human civilization. We are roughly halfway between North America and Europe. Above us, the surface waters are deep and restless. But we are leaving the turbulent waves behind. The Atlantic Ocean covers 20% of Earth's surface. It formed millions of years ago when continents divided. The water above our sight is incredibly deep. We begin our slow dive into the water column. Sunlight starts to fade as we move downward. The bright blue surface hues turn into a deep twilight. We pass through the epipelagic zone near the surface. This is where sunlight still warms the ocean water. Slowly, the water temperature begins to drop around us. We cross the invisible boundary of the ocean thermocline. Here, the temperature decreases rapidly with increasing depth. The ocean water becomes noticeably denser and much colder. We are entering the vast and quiet mesopelagic zone. The Atlantic Ocean has deeply stratified layers of water. We are sinking through the North Atlantic central water mass. This specific water layer has distinct salinity and temperature profiles. It originates from the surface waters of the northern latitudes. As it cools, it becomes heavy and sinks downward. This creates a slow, global circulation of ocean currents. The water surrounding us has traveled thousands of miles. It moves silently through the deep ocean basins. The deep currents here flow at a very leisurely pace. They carry vital dissolved oxygen to the deep sea floor. Without this oxygen, deep marine life could not survive. The salinity of the water here is remarkably stable. The salinity measures exactly 35 parts per thousand. This consistency helps maintain the delicate balance of the deep. There are no sudden changes in the deep ocean environment. The physical properties remain constant for centuries at a time. This profound stability is incredibly soothing to think about. The deep sea is free from the chaos of the surface. It is a realm of eternal. This isolated location remained hidden for a long time. Human eyes first saw this place in the year 2000. Scientists Deborah Kelly and Jeffrey Carson led the expedition. They were aboard the famous research vessel named Atlantis. The team was actually studying the surrounding underwater mountains. They used a deep-sea camera system called Argo 2. The discovery of the lost city was entirely accidental. They were conducting a routine survey of the seafloor. Suddenly, towering white structures appeared on their monitors. It was a groundbreaking moment for marine geology. No one had ever seen a hydrothermal system like this. The scientific community was completely fascinated by the finding. Later, the manned submersible Alvin visited the site directly. Researchers carefully mapped the exact coordinates of the field. They realized this was a completely new type of ecosystem. The location was named after the research vessel Atlantis. It also evoked the mythical sunken city. This region is defined by immense geological forces. We are approaching the Mid-Atlantic Ridge tectonic system. This is the longest continuous mountain range on our planet. It runs entirely underwater down the Atlantic Ocean floor. Here, the North American plate and Eurasian plate separate. They pull apart at a very slow geological pace. This spreading creates deep fractures in the ocean floor. However, the lost city is not on the ridge axis. It rests about 15 kilometers west of the spreading center. This specific placement makes its geology incredibly unique. Most known hydrothermal vents sit directly on volcanic ridges. The lost city occupies a different tectonic environment entirely. It sits atop an underwater mountain called the Atlantis Massif. The Atlantis Massif is a towering underwater geological feature. It rises sharply from the surrounding deep ocean floor. The mountain is formed by an oceanic core complex. Deep mantle rocks have been pushed upward to the surface. This tectonic process exposes ancient peridotite to the seawater. A massive detachment fault runs through this underwater mountain. This fault allowed the deep mantle rock to rise. The surface of the fault is heavily corrugated and grooved. These deep grooves span kilometers across the mountain face. They were carved by immense tectonic friction over millennia. But we are now reaching our precise target depth. The lost city rests at 800 meters below. Some structures reach slightly higher to 700 meters. At this depth, the physical environment is incredibly extreme. The hydrostatic pressure is roughly 80 times atmospheric pressure. Every square inch feels massive weight from the water column. The pressure increases by 1 atmosphere every 10 meters. Human bodies could never survive this crushing physical force. But our specialized submersible handles it with absolute ease. The thick titanium hull protects us from the deep ocean. The geometric sphere evenly distributes the massive external weight. Outside the hull, the water compresses slightly under pressure. This increases the overall density of the deep seawater. The water temperature here drops to 4 degrees Celsius. This near-freezing liquid flows slowly over the mountain rocks. The cold water is heavy and moves with deliberate slowness. Sound travels much faster through this highly pressurized liquid. Acoustic waves move swiftly across the barren underwater landscape. The immense pressure alters the physical properties of dissolved gases. It keeps certain chemical compounds completely dissolved in solution. We have officially entered the midnight zone of the ocean. Marine scientists call this deep region the bathypelagic zone. Absolutely no sunlight can penetrate down to this depth. The darkness outside our viewport is absolute and eternal. It has been completely dark here for millions of years. Red light wavelengths were absorbed near the ocean surface. Blue light faded entirely just a few hundred meters above. Now, there are no photons left from the distant sun. The only light comes from our submersible vehicles. Our powerful artificial beams cut through the pitch-black water. They illuminate the swirling particles of falling marine snow. This marine snow consists of organic debris from above. It drifts down slowly like a gentle winter storm. Occasional bioluminescent creatures drift past our glowing exterior lights. They flash briefly in the cold, silent ocean void. The absence of sunlight means no photosynthesis occurs here. Life must find another way to survive the permanent darkness. This eternal night creates a perfectly calm. Let us examine the surrounding seafloor terrain more closely. We are hovering near the summit of the Atlantis Massif. The terrain here is rugged, steep, and completely alien. Vast underwater cliffs drop off into the unseen abyss. The southern wall of the Massif is incredibly steep. It plunges down to the Atlantis fracture zone below. We navigate carefully along this dramatic underwater cliff face. The rock formations here are millions of years old. The mountain summit is somewhat dome-shaped and gently curved. However, the flanks are scarred by ancient geological collapses. Large debris fields sit at the base of the cliffs. These fields contain massive boulders of fallen mantle rock. The older rocks are covered in thick pelagic ooze. This soft sediment has accumulated over countless millennia. The pristine white marine snow blankets the dark grey rocks. We slowly glide over a terrace on the mountain side. This flat area provides a stable foundation for the vents. The surrounding crust is highly fractured and deeply faulted. Seawater seeps down into these countless cracks and crevices. It penetrates deep into the exposed mantle rock below. This downward flow as we are now getting much closer to the exact vent location. The sonar screen shows tall structures rising from the bottom. These are not normal geological rocks, but chemical mineral formations. The water chemistry around our submersible is subtly changing. Sensors detect a slight increase in the local water temperature. The alkaline pH level of the surrounding water is also gently shifting. We are entering the direct influence of the lost city. The currents here are gentle and highly predictable. They sweep slowly across the terrace of the Atlantis Massif. Everything in this deep environment moves at a glacial, peaceful pace. You can feel the profound silence of the deep sea. It is a silence that completely calms the restless mind. The immense weight of the ocean acts as a comforting blanket. It insulates us from the noise of the surface world. We are suspended in a dark, peaceful, liquid universe. Tonight's quiet journey has brought us to the threshold of discovery. We have now successfully navigated the deep Atlantic water column. We have finally located the ancient rocks of the story begins in the winter of 2000. A research vessel sailed across the dark ocean surface. This ship was the famous research vessel named Atlantis. It carried a team of dedicated marine oceanography experts. They navigated above the vast mid-Atlantic ridge formation. Cold winds brushed against the steel hull at night. Deep below them rested the massive Atlantis Massif mountain. This underwater mountain rises thousands of meters very steeply. The exact coordinates were 30 degrees north. Scientists wanted to study this massive crustal rock formation. They sought to understand deep oceanic tectonic fault lines. No one expected to find a hidden thermal system. The expedition was planned as a 30-day cruise. Lead scientists included Deborah Kelly and also Donna Blackman. Jeffrey Carson joined this critical geological ocean mapping mission. Their primary goal was purely geological mapping and sampling. Magma-driven black smokers were not their main target. They focused on the exposed mantled rock. Ocean waves gently rocked the large floating research vessel. The control room remained quiet during the night shift. Monitors glowed softly in the darkened main science laboratory. The team deployed a specialized deep-sea camera system. This instrument was the famous Argo two-towed vehicle. A fiber-optic cable connected it to the ship. Argo 2 glided silently above the dark ocean floor. It captured continuous video of the barren underwater landscape. Bright halogen lights pierced the eternal deep. Hours passed slowly in the quiet ship science laboratory. Only steep rocky cliffs appeared on the glowing screens. The depth reading showed exactly 800 meters down. Water pressure at this extreme depth is incredibly high. Temperatures outside the camera sled hovered very near freezing. It was the 4th of December in 2000. A routine observation watch shift was currently in progress. The ship moved at a very slow, steady speed. Ocean currents gently pushed against the thick. Suddenly the deep camera captured something completely unusual there. Pale, strange shapes emerged from the dark background shadows. The monitor displayed massive white crystalline solid rock structures. They looked like ancient ruined marble columns from Greece. Nothing like this existed in previous recorded oceanographic history. Black smokers are usually very dark and iron-rich. These mysterious new towers were bright white and pale. The scientists leaned closer to the glowing glass screens. They quickly recorded the precise deep sea. The name reflected its highly architectural and ghostly appearance. This unexpected find completely changed marine biology science forever. The ship crew prepared for a closer physical inspection. They needed to see the structures with human eyes. The famous Alvin submersible rested on the aft deck. Alvin is a specialized deep-ocean human-occupied vehicle. Mechanics checked the titanium pressure sphere very carefully indeed. Life support systems were verified before the morning dive. Deborah Kelly climbed into the small circular. An experienced pilot took the center vehicle observation seat. The heavy hatch was sealed tight against outside air. A large crane lifted Alvin off the wooden deck. The submersible was gently lowered into the blue water. Divers detached the safety lines from the white hull. Alvin began its slow descent into the dark abyss. Sunlight faded quickly as the heavy submersible sank deeper. The surrounding water turned from bright blue to black. Inside the sphere the air grew noticeably. The downward descent took over an hour of waiting. Sonars pinged softly to measure the approaching ocean bottom. At 700 meters the pilot activated exterior lights. The bright beam revealed a steep limestone cliff face. They navigated carefully along the rugged mountain rock terrace. Soon the massive white towers loomed into clear view. The sight was truly breathtaking in its silent majesty. Towering pale spires reached up towards the ocean surface. One giant central structure stood out from Poseidon, measures nearly 60 meters in total vertical height. This makes it taller than any known black smoker. The structure is formed entirely from solid calcium carbonate. Delicate flanges and mineral ledges decorate its pale sides. Warm fluid shimmered as it exited the porous rock. The Alvin pilot skillfully maneuvered the external robotic arms. They needed to collect pristine water and mineral samples. A long titanium temperature probe was inserted into vents. The strange readings puzzled the scientists. Inside the lost city, fluids were surprisingly much cooler overall. Temperatures ranged only from 40 to 90 degrees Celsius. This unique thermal profile was completely new to oceanography. Next, they measured the chemical acidity of the water. Standard hydrothermal vents pump out highly acidic dark fluids. These new vents release strongly alkaline clear water instead. The measured pH levels vary between 9 and 11. This closely matches the alkalinity of household ammonia solutions. The fluid chemical composition contained almost no high concentrations of methane gas were also detected there. Magma chambers did not provide the heat for this. The underlying heat source remained a fascinating geological mystery. Scientists soon realized a different chemical reaction was occurring. Seawater was interacting directly with exposed mantle peridotite rocks. This specific interaction is called the geological serpentinization process. Water molecules penetrate deep into the oceanic crustal faults. The ocean fluid binds with the iron-rich minerals. This chemical hydration process produces massive amounts. The newly altered green rock is known as serpentinite. This process can sustain hydrothermal activity for many millennia. Carbon dating eventually revealed the age of Lost City. These vents have been active for 30,000 years. This longevity far exceeds typical volcanic black smoker systems. The discovery shifted our entire understanding of planetary geology. We now know heat can exist without active volcanism. The implications for early Earth history are truly profound. Alkaline vents might have nurtured the first minerals act as natural catalysts for organic molecule formation. This remote location holds secrets to ancient biological origins. The Alvin crew spent hours documenting the strange landscape. High-definition cameras recorded the shimmering clear hydrothermal fluids. They observed delicate carbonate chimneys shaped like inverted cones. Some structures resembled weeping willow trees frozen in stone. Tiny white crabs crawled slowly across the mineral surfaces. The ecosystem survived entirely on the venting chemical energy. No sunlight ever reaches this deep Atlantic. It was time to begin the long ascent homeward. Heavy weights were dropped to restore positive vehicle buoyancy. Alvin floated gently upwards through the dark water column. The scientists organized their detailed handwritten scientific observation notes. They knew they had witnessed something historically very significant. The waiting ship crew welcomed them back onto deck. Water samples were immediately transferred to the chemistry lab. Rock fragments were carefully catalogued and stored in freezers. News of the discovery spread rapidly across. Future scientific expeditions were immediately planned to return there. In 2003, another major cruise was organized. This time they brought more advanced robotic mapping tools. Autonomous underwater vehicles surveyed the entire mountain ridge area. They mapped the precise fault lines driving fluid flow. The Atlantis Massif proved to be a complex structure. It is an oceanic core complex formed by extension. The Earth crust is pulled apart along detachment faults. This exposes the deep mantle rocks to subsequent dives revealed more intricate details of the towers. The calcium carbonate walls are highly porous and fragile. They break easily when touched by robotic metal manipulators. New mineral deposits form rapidly over the broken sections. The fragile chimneys can grow several centimeters every day. The warm venting fluids mix instantly with cold ocean. Calcium immediately precipitates to form the solid white walls. This creates a constantly evolving underwater architectural natural marvel. The discovery proved that life finds of these microscopic organisms coat the interior of the chimneys. They consume the methane and hydrogen gases for energy. Larger marine animals graze on these dense microbial biofilms. The local food web is simple but incredibly efficient. Every subsequent visit brings new scientific revelations to light. The National Science Foundation funded many of these trips. Scientists from various disciplines work together on the data. Geochemists analyze the rare isotopic signatures in the water. Biologists sequence the DNA of the strange. The lost city remains a unique natural deep laboratory. No other active alkaline field has been found yet. It stands completely alone in the vast ocean darkness. The white towers continue to vent warm fluid silently. They remain untouched by the passing of human centuries. The discovery of Lost City expanded our cosmic perspective. Astrobiologists study this place to understand alien ocean worlds. Moons like Enceladus might harbor similar alkaline hydrothermal systems. The serpentinization process could happen on distant. The deep sea truly holds keys to the universe. Its discovery story is a true testament to exploration. Curiosity drove those dedicated scientists into the dark ocean. Their careful observations opened a completely new science chapter. The RV Atlantis continued its mission across the waves. The Argo 2 camera sled was carefully stowed away. Alvin was washed down with fresh water after diving. The tired crew slept soundly as the ship steamed. Beneath them, the white spires stood in the ocean, kept its ancient rhythms undisturbed and calm. The scientific community forever remembers that fateful December night. A hidden world was finally brought into the light. This alkaline system continues to fascinate researchers worldwide today. Every newly gathered sample reveals another tiny biological secret. The towering carbonate pillars stand as silent deep sentinels. They guard the mysterious origins of life on Earth. The Lost City remains a beacon of scientific wonder. Its pale spires glow softly in our deep. Beneath the ocean surface lies the Mid-Atlantic Ridge. This massive underwater mountain range spans the entire globe. Tectonic plates slowly pull apart along this continuous boundary. The spreading rate here is incredibly slow and steady. It moves only about 25 millimeters every single year. This sluggish pace creates unique geological structures over time. Fast-spreading ridges create classic volcanic black smoke hydrothermal vents. The slow-spreading Mid-Atlantic Ridge operates under completely different rules. Magma supply is severely limited in this. The Lost City rests upon a massive underwater mountain. Scientists call this prominent geological feature the Atlantis Massif. The massif formed through a process called detachment faulting. A massive fault line sliced deeply into the rocky crust. This geological wound exposed rocks from the Earth's mantle. Mantle rocks rarely see the cold waters of the ocean. The primary rock type exposed here is called peridotite. Peridotite consists mostly of green olivine and dark pyroxene. These minerals are highly unstable in cold. A profound chemical reaction begins deep inside the rock. Geologists refer to this slow process as serpentinization. Olivine reacts with water to form a new mineral. This newly formed green mineral is known as serpentinite. The hydration reaction releases a significant amount of heat. Fluid temperatures rise steadily within the fractured rock layers. Temperatures reach between 40 and 90 degrees Celsius underground. This heat drives the unique hydrothermal circulation system upward. The circulating fluids undergo drastic chemical transformations. This alkalinity rivals that of household ammonia or bleach. The fluids also become enriched with dissolved calcium ions. Hydrogen gas and methane are produced during the reaction. These warm fluids eventually escape through the ocean floor. They meet the cold deep seawater at the surface. The surrounding ocean water has a slightly acidic pH. The mixing of these two distinct fluids triggers precipitation. Dissolved calcium reacts instantly with carbonates in the seawater. Solid calcium carbonate begins to build up layer. The chimneys are primarily composed of calcite and aragonite. Another mineral called brucite is also present in abundance. Brucite contains high amounts of magnesium and hydroxyl ions. These minerals create delicate flanges and towering white spires. The resulting structures look like giant stalagmites underwater. The geological age of the lost city is astonishing. Black smoke events typically last for only a few decades. They clog quickly with heavy metal sulfide mineral deposits. The lost city system operates on a much carbon isotopes show continuous activity for many millennia. Some chimneys have been growing for 30,000 years. The underlying hydrothermal system is at least 120,000 years old. This makes it the longest-lived hydrothermal system ever discovered. The slow serpentinization process guarantees a steady energy supply. The Atlantis Massif extends nearly 4,000 meters high. The lost city sits on a terrace near the summit. This terrace rests at a depth of 800 meters. The exact coordinates are 30 degrees. The research vessel Atlantis mapped this area in 2000. Geologist Deborah Kelly noticed strange structures on the monitors. She was observing camera feeds from a towed deep-sea sled. The camera sled was named the Argo 2 system. A massive white pillar suddenly appeared through the gloom. It was later named the Poseidon edifice by researchers. Poseidon stands an impressive 60 meters above the seafloor. It measures 20 meters across at its solid base. Geologist Jeff Carson co-directed the initial. The deep submergence vehicle Alvin carried scientists down safely. Alvin is a 3-person titanium sphere built for pressure. They observed the delicate mineral formations through thick portholes. The Alvin submersible carefully collected solid rock samples. Robotic arms gently broke off pieces of the chimneys. These samples were brought back to the surface laboratories. In 2005, another major scientific expedition visited the site. This mission utilized the research vessel named Ronald H. Brown. 2 remotely operated vehicles were deployed into the ROV. Argus provided bright illumination from high above. The detailed footage revealed complex geological textures and shapes. The chimneys feature porous walls filled with microscopic channels. These tiny channels allow hydrothermal fluids to seep outward. The outer surfaces often resemble dripping wax from candles. The internal mineral structure is highly organized and layered. Older chimneys eventually stop venting and become completely dormant. Without fresh fluids, the bright white minerals slowly degrade. They turn a dull gray or pale. This creates a thin dark crust over the carbonate. The entire field spans about 500 meters across. It is situated on a gently sloping limestone pavement. This underlying limestone is a breccia of broken rocks. Tectonic movements constantly shift and fracture the massif surface. Small earthquakes occasionally tremble through the deep crustal rocks. These tremors keep the fluid pathways open and active. Without these micro-earthquakes, the mineral veins would seal shut. The continuous fracturing allows seawater to reach the Atlantis Massif is considered an oceanic core complex. Core complexes form when tectonic plates pull apart asymmetrically. A single large detachment fault dominates the spreading center. The fault plane dips gently beneath the ocean floor. It acts like a massive geological conveyor belt over time. Deep mantle rocks are dragged upward along this slick surface. The exposed fault surface is heavily grooved and striated. Geologists call these linear features tectonic corrugations or mullions. They run parallel to the direction of plate. The lost city rests near the crest of this dome. The underlying mantle rocks are incredibly dense and heavy. Peridotite has a much higher density than typical basalt crust. The serpentinization process actually decreases the density of the rock. As water enters the crystal structure, the rock expands. This expansion causes severe fracturing throughout the rock mass. The volume of the rock can increase by 40%. This swelling creates even more pathways for cold seawater. It is a continuous self-sustaining geological strontium. Isotopes in the vent fluids match the mantle rocks. This proves the fluids interact deeply with the peridotite. The fluids have virtually no measurable dissolved metals inside. Black smokers are famously rich in iron and copper. The lost city fluids lack these heavy metallic elements entirely. This absence of metals prevents the formation of dark smoke. The fluids emerge crystal clear and shimmer in the lights. The optical distortion is caused by different water densities. Warm vent fluids are less dense than the thermal gradient is extreme over very short distances. The temperature drops from 90 degrees to barely 4 degrees. This dramatic cooling happens within just a few centimeters. The rapid temperature change forces rapid mineral crystal growth. Calcite crystals form delicate interlocking needles and flat plates. Aragonite creates beautiful radiating clusters of white mineral fibers. Brucite forms soft translucent layers within the chimney walls. The internal structure of a chimney resembles a sponge. There are countless interconnected voids and tiny fluid. The ROV Hercules had to use extreme caution during sampling. A gentle bump could collapse an entire delicate mineral spire. Some chimneys grow outward to form horizontal mineral flanges. Warm fluids pool underneath these flat, overhanging rocky ledges. The trapped fluids slowly percolate upward through the porous rock. This creates a shimmering mirror effect underneath the flange. The geological setting here is unique in the modern ocean. Similar environments may have been common on early Earth. The ancient oceans were much more alkaline. The lost city provides a window into the deep past. Geologists study this site to understand early planetary evolution. The formation of the Atlantis Massif took millions of years. The detachment fault began slipping nearly 2 million years ago. It slowly unroofed the deep mantle rocks over countless millennia. The fault plane is exposed for almost 20 kilometers. This makes it one of the largest known core complexes. The spreading center is located 15 kilometers to the east. The Rift Valley there contains typical basaltic. The Atlantis fracture zone forms the southern boundary of the massif. This deep transform fault cuts perpendicular to the spreading ridge. It creates a massive cliff face dropping into the abyss. The cliff exposes different layers of the oceanic crust. Scientists use this cliff to study the Earth's internal structure. Gabbro is another rock type found in the lower crust. Pockets of gabbro are scattered throughout the Atlantis Massif. These gabbro intrusions provide additional heat to the hydrothermal system. The cooling of these deep magma pockets, the interaction between gabbro and peridotite, creates complex chemistry. The lost city chimneys are concentrated in a small area. The active venting zone is roughly the size of a football field. There are over 30 large active chimney structures here. Hundreds of smaller dormant spires surround the main field. The sheer mass of precipitated carbonate is truly staggering. Geologists estimate millions of tons of rock have formed here. The continuous growth slowly buries the underlying limestone pavement. The chimneys sometimes merge together into massive composite for large venting cones sit atop the main Poseidon structure. They are named the Beehive, the Marker II, and others. The Beehive chimney has a distinctive rounded bulbous shape. Fluid flows outward evenly from the entire rounded surface. This creates a uniform precipitation pattern of fresh white minerals. The Marker II chimney is much taller and more slender. It channels fluid upward through a narrow central conduit. The geological forces shaping these forms are subtle and silent. Ocean currents slowly erode the older inactive carbonate. The delicate structures will eventually crumble back into the ocean floor. This dissolution process takes many thousands of years to complete. The balance between growth and decay is perfectly maintained here. The slow cycle of geological rebirth. Most hydrothermal vents exist along mid-ocean ridge boundaries. These active zones produce towering black smoker chimneys. Superheated fluids rush upward from beneath the crust. Temperatures often range from 350 to 400 degrees Celsius. Magma chambers deep underground provide this immense thermal energy. The extreme heat dissolves minerals from the surrounding rocks. Dark plumes billow into the freezing ocean water. These dark clouds contain high levels of dissolved metals. Iron and copper sulfides dominate. Their traditional black smokers grow rapidly in these volatile environments. Some chimneys can reach heights of 20 meters. The surrounding water remains close to freezing point. This sharp temperature gradient forces immediate mineral precipitation. Sulfur compounds rain down upon the surrounding basalt. The resulting structures appear dark and highly fragile. They frequently collapse under their own massive weight. New chimneys quickly form over the collapsed mineral debris. The cycle of growth and destruction. The lost city presents a completely different physical reality. We find no black smokers in this tranquil region. The coordinates stand at 30 degrees north latitude. The depth measures approximately 700 to 900 meters. This location sits far away from active spreading centers. No underlying magma chamber drives this particular hydrothermal system. Instead, we discover a vast field of white smokers. These pale structures rise like ghosts from the darkness. Their chemical composition differs entirely from traditional. The white chimneys glow dimly in the submersible lights. Aragonite and calcite crystallize to form these massive towers. The mineral deposits create complex and beautiful formations. Some structures resemble delicate stalagmites from terrestrial caves. Many other formations look like inverted frozen waterfalls. The fluid venting from these chimneys appears completely clear. You will not see dark, billowing clouds of smoke. The water simply shimmers as it mixes with seawater. This shimmering effect results from different fluid densities. Temperatures at the lost city remain remarkably moderate. The venting fluids never reach 400 degrees Celsius. Instead, They range between 40 and 90 degrees Celsius. This gentle warmth creates a soothing underwater environment. The heat originates from a slow chemical reaction. Ocean scientists call this specific geological process serpentinization. Seawater percolates deep into the exposed mantle rock. The water reacts chemically with the mineral olivine. This exothermic reaction naturally releases a steady. The newly formed mineral is known as serpentinite. This chemical transformation also produces highly alkaline fluids. The pH levels of these fluids reach up to 11. Such high alkalinity resembles household ammonia or bleach. The fluid carries dissolved hydrogen and methane gases. These gases dissolve quietly into the surrounding ocean currents. The warm, alkaline water eventually meets the cold ocean. Calcium carbonate immediately precipitates out of the solution. This continuous precipitation slowly builds the unlike black smokers. These white chimneys grow over millennia. Carbon dating reveals their truly ancient geological origins. Some structures have vented fluids for 30,000 years. This extreme longevity allows them to reach staggering heights. The largest structure in the field commands immediate attention. Researchers have named this massive chimney the Poseidon edifice. Poseidon stands an incredible 60 meters above the seafloor. It rivals the height of an 18-story building. The sheer scale of this white tower, the massive Poseidon edifice, features multiple venting spires. Delicate carbonate flanges extend outward from the main trunk. These horizontal flanges trap pools of warm, shimmering water. The trapped fluids create inverted reflective pools underwater. The submersible lights bounce off these mirrored liquid surfaces. Slowly growing stalactites hang beneath the carbonate overhangs. The physical structure appears both monumental and highly fragile. A careless movement from the submersible could cause damage. The pilots navigate the ROV Jason with extreme. Many smaller chimneys surround the central Poseidon structure. Scientists have mapped over 30 distinct active vent sites. Some extinct chimneys stand quietly in the dark distance. These older structures have stopped releasing warm fluids entirely. Their white surfaces gradually turn gray over many centuries. Manganese deposits slowly coat the inactive carbonate spires. The active chimneys maintain their bright, ghostly white color. The continuous flow of alkaline water prevents mineral darkening. The contrast between active and inactive vents. We examine the structural integrity of the white smokers. The outer walls consist of highly porous carbonate material. This sponge-like texture allows ocean water to seep inward. The inner channels transport the warm alkaline fluids upward. Microscopic pores create a vast network of internal plumbing. These tiny chambers provide sheltered environments for chemical reactions. The physical architecture perfectly supports deep ocean fluid dynamics. The chimneys act as natural chemical mixing zones. Iron and sulfur are notably absent from the research team collects physical samples for laboratory analysis. A robotic arm reaches toward a small carbonate spire. The titanium claws gently grasp the fragile white rock. With a slight twist, the sample breaks away cleanly. The arm places the rock into a collection basket. This specific sample will undergo extensive isotopic testing later. Scientists want to understand the exact precipitation sequence. They study how the calcium carbonate layers slowly accumulate. Each microscopic layer tells a story of the absence of magma, makes this system incredibly stable. Volcanic black smokers can shut down without any warning. Earthquakes frequently disrupt the plumbing of traditional vent fields. The lost city experiences very little seismic disruption. The slow serpentinization process guarantees a steady fluid supply. This geological stability persists through major climate shifts above. The white chimneys have survived multiple terrestrial ice ages. They remain isolated from the chaotic surface world above. The deep ocean provides a perfectly insulated. Let us review the distinct differences in vent systems. Black smokers require intense volcanic heat to function properly. They emit fluids at 350 to 400 degrees Celsius. Their dark plumes carry heavy metals and acidic water. The lost city relies entirely on chemical rock reactions. Its fluids remain below the boiling point of water. The white chimneys release highly alkaline and clear fluids. These physical differences rewrite our understanding of oceanography completely. Dr. Robert Ballard noted the importance of the structural complexity of the lost city is mesmerizing. Some chimneys merge together to form massive composite walls. These carbonate walls stretch for hundreds of meters horizontally. The terrain feels like a submerged mountain range. Deep crevices cut through the underlying peridotite bedrock. Fault lines expose the ancient mantle rocks to seawater. The entire Atlantis Massif acts as a giant sponge. Water circulates deep within the fractured mountain core. The journey back to the surface takes many. The camera pans across the side of the Poseidon edifice. We observe the intricate textures of the carbonate surface. Small mineral flakes drift downward in the gentle current. The submersible hovers silently in the pitch-black water. Only the artificial lights illuminate this hidden geological world. Shadows stretch long and dark behind the towering chimneys. The scale of the structures dwarfs our technological vessels. It took thousands of years to build these. Measurements show the fluid velocity is remarkably slow here. Black smokers often violently eject fluids into the ocean. The lost city vents simply weep their warm waters. This gentle weeping allows delicate crystal formations to survive. Fast currents would easily destroy the fragile carbonate flanges. The calm environment perfectly preserves the towering white pillars. Sonar readings map the exact dimensions of the field. The active zone covers roughly 400 square meters. This relatively small area holds immense scientific. The chemical composition hints at processes on other planets. Similar alkaline vents might exist on distant icy moons. The physical structures provide a template for extraterrestrial exploration. Our understanding of planetary geology expands with every observation. The ROV Jason continues its slow photographic survey. High-definition cameras capture every millimeter of the white chimneys. The visual data travels up the fiber-optic cable. Scientists on the Atlantis analyze the images in real time. They catalog the varied shapes of the sun. Spires look like the spiraling horns of unicorns. Others form broad, flat canopies over the venting fissures. The structural diversity arises from subtle shifts in flow. Even a slight change in temperature alters the crystallization. The physical environment remains in a state of balance. The slow precipitation perfectly matches the gentle fluid release. There is a profound sense of peace down here. The towering white monoliths stand as silent, eternal. Let the slow rhythm of the deep ocean calm you. Visualize the white chimneys rising from the dark seafloor. Imagine the warm, shimmering water mixing with the cold. The temperature difference creates a beautiful, hypnotic visual distortion. The massive Poseidon edifice stands tall in your mind. Its 60-meter height represents thousands of years of patience. The deep ocean operates on an incredibly vast timescale. Our brief human concerns fade away in this. The submersible prepares to end its current observation dive. Ballast tanks slowly adjust for the long upward journey. The ROV Jason pulls back from the carbonate towers. The bright lights sweep across the field one last time. The ghostly white smokers gradually fade into the gloom. The darkness of the deep ocean reclaims the landscape. The cold water embraces the ancient, towering mineral structures. The lost city returns to its endless, silent. We now descend deeper into the chemical mysteries of this realm. The surrounding seawater holds a standard pH of roughly 8. Ocean currents bring cold water toward the towering carbonate structures. Inside these porous towers, a profound chemical transformation silently occurs. The fluid emerging from the vents is entirely different here. Sensors on the ROV Jason record a sudden environmental shift. The water chemistry changes drastically within just a few centimeters. This is a unique alkaline environment unlike any other discovered. The hydrothermal fluids boast an extreme pH of 11. Such high alkalinity resembles the harsh chemistry of household ammonia. Yet life finds a way. Typical mid-ocean ridge vents produce highly acidic black smoke. Those traditional systems operate at a very low pH level. Black smoker fluids often measure around 2 or 3. They spew dark clouds rich in heavy dissolved metals. Lost City presents a stark contrast to those violent systems. Here, the venting fluids are completely clear and transparent. No dark clouds of metallic smoke obscure the ocean water. The high pH prevents iron and zinc from dissolving easily. Instead, the water is saturated with dissolved calcium and carbonate. Scientist Deborah Kelly first noted this anomaly during early dives. Her team observed the shimmering. This unique chemistry originates deep within the Atlantis Massif. The field sits exactly at 30 degrees north latitude. It lies along the vast underwater mountain range of the Mid-Atlantic Ridge. Seawater slowly percolates through cracks in the ancient mantle rock. The primary mineral here is iron-rich olivine from the mantle. As water touches the olivine, an exothermic reaction begins. Geologists refer to this slow geological process as serpentinization. The rock actually swells and changes its internal crystal structure. This chemical alteration generates significant amounts of natural heat. Temperatures within the crust rise to roughly 90 degrees Celsius. This is much cooler than the boiling black smoker systems. Black smokers routinely exceed 350 degrees Celsius. The gentle heat at the serpentinization reaction produces massive quantities of dissolved hydrogen gas. Hydrogen concentrations here are incredibly high for a marine environment. They are orders of magnitude greater than typical hydrothermal vents. This dissolved hydrogen is a potent source of chemical energy. Microbes use this invisible gas to power their basic metabolism. The fluid samples were carefully analyzed aboard the research vessel. Scientists on the RV nor measured these unprecedented gas levels. Every liter of vent fluid contains millimoles of pure hydrogen. This energy source requires absolutely no sunlight to sustain life. The deep-sea ecosystem relies entirely on this underground chemistry. The constant flow of hydrogen shapes alongside hydrogen. The vent fluids carry abundant dissolved methane gas. Most methane on Earth comes from the decay of biological matter. However, the methane at Lost City has a different origin. It forms through purely abiotic chemical reactions inside the rocks. Carbon dioxide from seawater reacts directly with the dissolved hydrogen. This inorganic process creates simple organic molecules like methane. Geochemist Gretchen Frue-Green studied these specific carbon isotope ratios. Her research proved the gas was not made by ancient life. The mantle rocks simply act as a giant chemical factory. This discovery shifted our understanding of deep ocean chemistry. It showed how organic compounds, the salinity of the Lost City fluids is also highly unusual. Typical seawater maintains a relatively stable salt concentration throughout. The vent fluids here show significant fluctuations in their salinity. Some areas release water that is much saltier than the ocean. Other vents emit fluids with surprisingly low salt content. These variations point to complex phase separations deep underground. Water molecules interact differently with the rocks at high pressures. Salt ions are left behind or concentrated in narrow mineral veins. The deep submersible Alvin collected numerous samples of this water. Titanium syringes captured the fluids without altering their delicate chemistry. Laboratory analysis revealed the exact mineral. Another striking feature is the near absence of hydrogen sulfide. Most hydrothermal vents are defined by the smell of rotten eggs. That toxic sulfide gas fuels the giant tube worms of the Pacific. At Lost City, sulfide concentrations are barely detectable by instruments. The alkaline chemistry prevents sulfur compounds from remaining dissolved. Any available sulfur quickly precipitates out deep within the crust. This creates an environment entirely free of toxic sulfide gas. The organisms here evolved without relying on sulfur oxidation. They depend exclusively on the abundant methane and hydrogen instead. This fundamental chemical difference isolates the local biological community. Species from black smokers simply cannot. Just a few miles away lies the TAG hydrothermal field. TAG is a classic black smoker system on the mid-ocean ridge. The chemical contrast between these two sites is truly staggering. TAG vents spew acidic, metallic fluids at 300 degrees. Its towering chimneys are made of dark copper and iron sulfides. Lost City builds its quiet towers from pure white calcium carbonate. TAG sits directly above a shallow, active volcanic magma chamber. Lost City rests on an uplifted block of solid mantle rock. The heat source at TAG is intense and short-lived. The serpentinization at Lost City can last for millions of years. Scientists often compare these two. The upward flow of alkaline fluid is remarkably slow and gentle. Black smokers blast water into the ocean like fire hoses. Lost City fluids simply seep out of tiny pores and cracks. They form shimmering pools beneath the overhanging carbonate flanges. The warm fluid is less dense than the surrounding cold seawater. It slowly creeps upward along the sides of the massive towers. This gentle mixing creates a complex gradient of temperatures. Microbes position themselves exactly where the chemical mixture is perfect. Sensors detect microenvironments with vastly different chemical signatures. A distance of 1 millimeter can mean a huge chemical change. The ROV Jason mapped these tiny chemicals as the alkaline fluid meets seawater. A dramatic reaction occurs. The high pH causes calcium carbonate to instantly precipitate out. This is the exact process that builds the towering structures. Solid rock forms directly from the mixture of two clear liquids. Aragonite and calcite crystals grow steadily in the dark water. The fresh mineral deposits are incredibly fragile and easily crushed. They resemble delicate spun sugar or soft porous sponges. Over thousands of years, these soft deposits slowly harden into limestone. The chemical precipitation traps small pockets of fluid within the rock. These tiny fluid inclusions preserve a record of past ocean chemistry. Geologists slice the rocks thinly to study the exact depth plays a crucial role in this chemical system. Lost City sits between 700 and 900 meters down. This is relatively shallow compared to most mid-ocean ridge vents. The water pressure here is about 80 times atmospheric pressure. This specific pressure allows the gases to remain dissolved in solution. If the site were shallower, the methane would bubble away quickly. If it were deeper, the carbonate structures might dissolve back into water. The Atlantis Massif provides the perfect elevation for this chemical balance. Oceanographer Jeffrey Carson mapped the steep faults of this underwater mountain. His detailed bathymetric surveys revealed the exact geological setting. The towering limestone structures cling to the side. Deep ocean water brings dissolved oxygen to the vent field. The warm hydrothermal fluids contain absolutely no oxygen at all. Where these two water masses meet, a sharp chemical boundary forms. This interface is where the most intense biological activity occurs. Microbes use the oxygen to burn the hydrogen and methane fuels. The chemical energy released sustains a vast, invisible food web. Sensors drop through the water column to measure the oxygen depletion. They detect exactly where the microbes are consuming the dissolved gases. The mixing zone is only a few millimeters thick in places. Yet this microscopic layer is the engine of the entire ecosystem. The slow currents constantly radiocarbon dating reveals the incredible age of these chemical reactions. Some carbonate samples are over 120,000 years old. This makes Lost City one of the longest-lasting vent systems known. Black smokers typically clog up and die after a few decades. The acidic fluids eventually destroy the very chimneys they create. The alkaline chemistry here is far more stable and enduring. The serpentinization process provides a steady, unrelenting supply of energy. There is enough mantle rock to keep this system running indefinitely. Scientists believe this slow chemistry could last for millions of years. The chemical environment remains remarkably constant over vast stretches of time. This stability allows unique biological communities. This unique environment offers clues to the origins of life. The early Earth possessed a very similar chemical makeup. Billions of years ago, the oceans were rich in dissolved iron. Alkaline vents like Lost City may have dotted the primordial seafloor. The porous carbonate rocks provide natural compartments for chemical reactions. Inside these tiny pores, organic molecules could concentrate and combine. The natural temperature gradients drive complex chemical synthesis. The abundant hydrogen and methane provide the necessary building blocks. Many scientists view these alkaline vents as the cradle of life. The research vessel Atlantis continues to study this fascinating hypothesis. Each water sample brings us closer to looking through the cameras of ROV. Jason reveals this chemical truth. The shimmering water distorts the light from the submersible vehicles. This optical illusion is caused by the mixing of different fluid densities. The hot, fresh vent water bends the light rays sharply. It looks like a mirage hovering over a hot desert highway. The white towers stand silently in the eternal darkness of the abyss. They are monuments to the quiet power of alkaline chemistry. There is no violent eruption or boiling water here. Just the slow, steady transformation of rock and seawater into life. The chemical signature of Lost City is a rare oceanic treasure. It challenges everything we thought we knew. The biological community of the Lost City is truly unique. Dr. Deborah Kelly first documented these organisms in the year 2000. Life here exists without any sunlight or typical volcanic heat. Instead, creatures rely entirely on a process called serpentinization. This chemical reaction provides hydrogen and methane for survival. The biomass here differs greatly from typical black smoker vents. Black smokers host massive tube worms and giant white clams. The Lost City features a much more subtle ecosystem. Organisms here are mostly microscopic or very small. Researchers returned to the site during a 2003 deep expedition. They deployed the remotely operated vehicle Hercules for close inspection. Hercules descended to a depth of 800 meters. The vents sit near 30 degrees north in the Atlantic. The total biomass at the Lost City is relatively low. Scientists measure only a few grams of carbon per square meter. However, the population density of specific microfauna is incredibly high. Thousands of tiny organisms occupy small patches of carbonate rock. They thrive in a highly alkaline environment with a pH of microbial mats form the absolute foundation of this marine food web. These thick biofilms coat the porous walls of the white chimneys. They appear as translucent or pale yellow patches on the rock. The mats are only a few millimeters thick in most places. Gentle currents from the venting fluids constantly wash over them. The water temperature here ranges from 40 to 90 degrees Celsius. Microbes cling directly to the calcium carbonate structures for stability. They do not need organic detritus falling from the ocean surface. Instead, they consume the raw gases bubbling up from a specific group of archaea dominates these thick microbial mats. Scientists classify them within the order known as Methanosarcinales. These rare organisms possess highly specialized metabolic pathways. They process the abundant methane trapped within the vent fluids. Dr. Gretchen Frue-Green analyzed their unique carbon isotope signatures. This research proved that these archaea are entirely endemic. They exist nowhere else in the global ocean system. Their cellular structures tolerate the harsh alkaline conditions perfectly. Methanosarcinales form dense clusters inside the microscopic pores of the chimneys. Specific bacteria live in strict symbiosis with these unique archaea. These bacteria form the second crucial component of the microbial mats. They process sulfur compounds found in the surrounding cold seawater. Together, the archaea and bacteria create a highly efficient chemical factory. They exchange nutrients and metabolic byproducts in a closed loop. This symbiotic relationship maximizes energy extraction from the vent fluids. Scientists observed this interaction using advanced electron microscopy techniques. The biofilm matrix protects both organisms from sudden temperature shifts. It also shields them from toxic heavy metals. Nematodes represent the most abundant animal life at the Lost City. These microscopic roundworms wriggle through the dense microbial mats. They feed directly on the thick layers of bacteria and archaea. Researchers counted thousands of individual nematodes in a single rock sample. Their population densities far exceed those found in surrounding ocean sediments. Nematodes possess slender, transparent bodies that blend into the biofilm. They lack eyes, relying entirely on chemical sensors to navigate. These sensors detect faint traces of hydrogen sulfide and methane. The worms move slowly, conserving energy in the dark. Small gastropods crawl along the towering calcium carbonate spires. These tiny snails are the dominant macrofauna of the vent field. Their shells measure only 2 to 3 millimeters in diameter. The shells are incredibly thin and nearly transparent in the lights. High alkalinity makes building thick calcium carbonate shells quite difficult. Therefore, the snails invest minimal energy into their protective armor. They graze peacefully on the edges of the active microbial mats. Many of these snail species are strictly endemic to the lost city. Genetic analysis reveals they diverged from other ocean snails. Millions of amphipods also inhabit the crevices of the white limestone towers. These tiny crustaceans resemble pale, miniature shrimp under the camera lights. They act as the primary scavengers of the lost city ecosystem. Amphipods consume dead organic matter that drifts away from the biofilms. They possess specialized appendages for sweeping microscopic particles into their mouths. Their population numbers are small compared to the abundant nematodes. However, they represent a crucial link in the local food chain. Amphipods navigate the steep vertical walls of the chimneys with ease. They avoid the hottest venting fluids, preferring the cooler polychaete. Worms hide deep within the porous structure of the chimneys. Unlike the giant tube worms of black smokers, these are tiny. They rarely exceed 1 centimeter in body length. These bristle worms construct delicate, temporary tubes out of mineral debris. They extend feathery gills into the water to extract dissolved oxygen. The oxygen levels in the surrounding deep seawater are relatively low. Polychaetes must carefully position themselves to maximize their respiratory efficiency. They feed by filtering loose bacteria from the gentle vent currents. Scientists collected several previously unknown species of polychaetes during the 2005 Astrocards dart quickly through the warm water surrounding the active vents. Researchers often call these tiny creatures seed shrimp due to their shape. They possess a bivalve shell that protects their delicate inner bodies. Astrocards swim using a pair of powerful, microscopic antennae. They are highly sensitive to sudden changes in water temperature. This sensitivity keeps them safely away from the boiling vent fluids. They primarily consume loose bacteria suspended in the alkaline water column. Their rapid movements provide a stark contrast to the slow snails. Astrocards contribute to the overall biodiversity of this isolated bivalves are exceedingly rare within the central lost city vent field. Scientists have found only a few small clams on the extreme periphery. These clams inhabit areas where the vent fluids mix heavily with seawater. The water here is much cooler and slightly less alkaline. The clams host symbiotic bacteria within their pale, fleshy gills. These bacteria assist in processing the faint traces of available methane. However, the low concentration of hydrogen sulfide limits their growth. Therefore, the clams never reach the massive sizes seen at other vents. They remain small, fragile, and widely dispersed across the rocky. The food web of the lost city is remarkably short and simple. Energy transfers directly from the chemical gases to the microbial mats. From the mats, energy flows to the grazing snails and nematodes. There are absolutely no large apex predators residing in this ecosystem. Researchers have never observed crabs or large fish hunting among the chimneys. The extreme alkalinity likely deters complex, large marine animals from entering. This absence of predators allows the tiny endemic creatures to thrive peacefully. They do not need complex defensive mechanisms or heavy protective shells. The community relies entirely on steady chemical production rather. Endemism is a defining characteristic of the Lost City biological community. Over 50% of the species found here exist nowhere else. This high rate of unique species fascinates evolutionary biologists worldwide. The Atlantis Massif acts as an isolated island in the deep sea. Ocean currents rarely carry larvae from other vent systems to this location. The specific chemical signature of the alkaline vents creates a strict barrier. Organisms adapted to acidic black smokers simply cannot survive in this water. Therefore, the creatures of the Lost City have evolved in complete isolation. They represent millions of years of highly researchers utilize specialized sampling equipment to study these fragile organisms. The vehicle Hercules carries a gentle suction device known as a slurp gun. This tool carefully vacuums the tiny snails and amphipods from the rock. It deposits them into separate, sealed acrylic canisters for the ascent. Scientists also collect intact pieces of the porous carbonate chimneys. These rock samples preserve the delicate spatial arrangement of the microbial mats. Aboard the research vessel, biologists examine the samples inside chilled laboratories. They must maintain the low temperatures of the deep ocean environment. Warming the samples would quickly destroy the specialized enzymes of the spatial distribution of life heavily depends on the fluid flow. Organisms cluster tightly around the active venting orifices of the chimneys. Here, the steady supply of methane and hydrogen fuels continuous growth. Moving just a few meters away, the biological density drops dramatically. The inactive, older chimneys host very little living biomass. Without the chemical fluids, the microbial foundation quickly starves and dies. The white limestone slowly turns gray as the organic material degrades. This creates a stark visual contrast between living and dead mineral structures. Life at the Lost City is intimately tied to the geological activity. Carbonate precipitation constantly alters the physical habitat of these creatures. As the alkaline fluids meet seawater, fresh minerals instantly crystallize. This ongoing process frequently blocks the narrow venting pores in the rock. When a pore clogs, the vital chemical fluids must find a new path. The microbial mats and grazing animals must slowly migrate to the new vent. This creates a dynamic, shifting biological landscape on the chimney walls. Organisms must continuously adapt to the changing flow of their life source. Despite this constant physical change, the overall community structure remains highly stable. Generations of microscopic life rise and fall with the shifting. Scientists often compare the Lost City microbes to ancient Earth life. A billion years ago, early oceans were highly alkaline and warm. Similar serpentinization reactions likely provided the first chemical energy for life. The Methanosarsenales archaea may closely resemble our most distant cellular ancestors. Studying their simple metabolic pathways offers clues to the origins of biology. They demonstrate how life can emerge from bare rock and raw gas. No sunlight deep beneath the Atlantic Ocean waves lies a hidden world. The Lost City hydrothermal field defies all biological expectations. This ecosystem operates entirely without the energy of sunlight. Life here relies on a rare geological process called serpentinization. Mantle rocks react with seawater to produce life-sustaining gases. This chemical reaction generates abundant hydrogen and methane gases. These simple molecules form the foundation of a complex food web. Organisms here do not consume organic matter from the surface. Instead, they harvest chemical energy directly from the earth. This process is known to scientists as chemosynthesis. The resulting ecosystem is unlike any. Most hydrothermal vents expel highly acidic, mineral-rich black smoke. The lost city towers release clear, highly alkaline fluids. The water emerging from these chimneys has a pH of 11. This alkalinity matches the chemical profile of liquid ammonia. Temperatures of the venting fluids range from 40 to 90 degrees. These moderate temperatures create a perfect sanctuary for extremophile microbes. The surrounding ocean water remains at a frigid 4 degrees. Where these contrasting waters meet, calcium carbonate precipitates rapidly. This precipitation builds massive white spires reaching 60 meters tall. These porous carbonate structures provide vast surface areas for life. Microorganisms colonize the microscopic crevices. Single-celled organisms are the primary producers of this deep ecosystem. They belong to ancient lineages known as archaea and bacteria. Methanos arsenales archaea dominate the interior zones of the carbonate chimneys. These ancient microbes thrive in the oxygen-depleted, warm vent fluids. They consume the abundant methane gas bubbling from the seafloor. This consumption converts raw chemical energy into biological carbon. On the cooler exterior surfaces, different bacterial communities flourish. These exterior microbes oxidize hydrogen and sulfur compounds for energy. Together, these microbial mats form the base of the food chain. They create a thick, nutrient-rich slime coating the white spires. This biological layer sustains all other life. Tiny grazing invertebrates feed directly upon the microbial biofilms. Microscopic nematodes weave through the porous calcium carbonate structures. Small gastropods cling to the sheer vertical walls of the chimneys. These snails scrape the bacterial mats using specialized feeding bullers. A unique species of transparent amphipod swims among the spires. These tiny crustaceans filter suspended microbes from the surrounding water. Polychaete worms construct delicate tubes along the mineral surfaces. They extend feathery appendages to capture passing organic particles. Ostracods dart through the shimmering thermal gradients near the vents. Their bivalve-like shells protect them from the harsh alkaline fluids. These primary consumers convert microbial mass. Larger animals are surprisingly rare in the lost city ecosystem. This scarcity contrasts sharply with the crowded black smoke events. However, a few specialized predators patrol the white carbonate towers. Pale, blind brachyuran crabs scavenge along the chimney bases. They use sensitive antennae to detect the movements of small snails. Predatory sea spiders slowly traverse the uneven mineral landscapes. Their long, spindly legs allow them to navigate the strong currents. Occasional deep-sea cutthroat eels glide silently between the towering spires. These fish hunt for unwary crustaceans in the perpetual darkness. Wreckfish sometimes visit the upper reaches of the tallest chimneys. They use the massive structures as shelter. Black smoker ecosystems rely entirely on volcanic heat and magma. They are driven by the oxidation of hydrogen sulfide gas. Giant tube worms and massive clam beds dominate those volcanic vents. The lost city possesses none of these iconic deep-sea creatures. Its tectonic driving forces create a much gentler chemical environment. The biomass at the lost city is significantly lower overall. Yet, the biodiversity of microscopic life is astonishingly high here. Black smokers often last only a few decades before clogging. The lost city system has remained active for over 30,000 years. This incredible stability allows for slow, deliberate evolutionary adaptations. Organisms here have optimized the research vessel Atlantis first discovered this site in the year 2000. Scientist Deborah Kelly recognized the profound biological significance immediately. The deep submergence vehicle Alvin descended to explore the alien landscape. Alvin operates at a depth of nearly 800 meters here. Later missions utilized the remotely operated vehicle named Jason. Jason captured high-definition video of the delicate biological communities. Scientists deployed specialized titanium syringes to sample the vent fluids. These samples revealed the extraordinary concentration of dissolved hydrogen. Researchers also collected pieces of the porous carbonate rock. Laboratory analysis confirmed the presence of dense microbial communities inside. Genetic sequencing revealed entirely new branches on carbon dioxide dissolved in seawater plays a crucial role here. Microbes extract this carbon to build their cellular structures. The energy for this process comes from breaking chemical bonds. Hydrogen acts as the primary electron donor in this dark world. Sulfate molecules from the ocean water serve as electron acceptors. This microscopic electrical circuit powers the entire lost city ecosystem. Methane production is a natural byproduct of these biological reactions. Some methane is also generated purely by the geological serpentinization. Distinguishing biological methane from geological methane challenges modern science. Isotopic analysis helps researchers trace the complex carbon pathways. The ecosystem operates as a perfectly. The lost city sits atop an underwater mountain called the Atlantis Massif. This mountain exposes deep mantled rock directly to the cold ocean. The mineral olivine makes up a large portion of this exposed rock. Olivine hydration is the true engine of the local food web. The chemical reactions cause the rock to expand and fracture. These fractures allow seawater to penetrate deeper into the crust. This continuous circulation sustains the steady flow of alkaline fluids. The physical structure of the mountain shapes the biological community. Strong bottom currents sweep across the summit of the massif. These currents deliver essential trace metals to the localized vent organisms. They also disperse the microscopic. The extremophiles of the lost city possess unique cellular membranes. These membranes withstand the highly basic pH of the vent fluids. Standard biological proteins would rapidly denature in such alkaline conditions. The resident microbes have evolved specialized enzymes to survive. These enzymes function optimally at a pH of 10 or higher. Researchers study these proteins for potential industrial and medical applications. The lack of sunlight means these organisms lack protective pigmentation. They are completely vulnerable to ultraviolet radiation at the surface. However, beneath 800 meters of water, they are perfectly safe. The crushing hydrostatic pressure also influences their cellular biology. Pressure at this depth is 80 times. Symbiotic relationships define survival in many deep-sea environments. At the lost city, symbiosis takes subtle and microscopic forms. Certain bacteria live entirely within the tissues of the deep-sea snails. These internal guests process toxic compounds for their invertebrate hosts. In return, the snails provide a stable, nutrient-rich environment. Sponges attach themselves to the older, inactive sections of the chimneys. These sponges harbor diverse communities of nitrogen-fixing bacteria. Nitrogen is a scarce and valuable resource in the deep ocean. The bacteria convert dissolved nitrogen gas into usable biological ammonia. This ammonia eventually cycles through the entire localized food web. Every organism here depends on that the lost city does not exist in complete biological isolation. It interacts subtly with the broader Atlantic Ocean ecosystem. Plankton falling from the sunlit surface rarely reaches these vents. The strong currents sweep most pelagic snow away from the massif. However, mobile predators occasionally link the vents to the pelagic zone. Deep-diving sharks sometimes pass through the warm thermal plumes. These brief visits leave trace amounts of organic waste behind. Scavenging amphipods quickly consume any foreign material that settles here. The vent fluids also inject rare minerals into the ocean water. These minerals eventually support distant microscopic life in the open sea. The lost city is a vital chemical oasis. Many scientists believe early Earth resembled the lost city ecosystem. A billion years ago, our oceans were acidic and iron-rich. Alkaline hydrothermal vents would have provided natural chemical gradients. These gradients could have powered the very first living cells. The porous carbonate chimneys act like primitive cellular compartments. They concentrate organic molecules in safe, warm, microscopic pockets. The natural electrical potential across the chimney walls mirrors cellular biology. This proton gradient is the fundamental energy mechanism of all life. Studying the lost city microbes helps us understand our own origins. It proves that life can emerge without the energy of a star. This realization profoundly impacts that the biological balance within the lost city is incredibly delicate. The slow growth rate of the carbonate chimneys dictates biological expansion. Chimneys grow upward at a rate of just a few centimeters annually. If a spire collapses, the local microbial community is instantly destroyed. It takes decades for the fragile ecosystem to fully recover. Natural seismic activity along the mid-Atlantic ridge occasionally causes structural damage. Yet, the steady flow of alkaline fluid eventually rebuilds the towers. New microbial mats quickly colonize the freshly precipitated mineral surfaces. The grazing snails return to feed on the renewed bacterial growth. This cycle of destruction and renewal has continued for millennia. It reflects the quiet. The lost city remains a beacon of biological endurance. It challenges our traditional definitions of a habitable environment. In the absolute darkness, chemical energy weaves a tapestry of life. The pale chimneys stand as silent monuments to biological innovation. Each microscopic organism plays a vital role in the food web. The gentle venting of warm fluid sustains this hidden sanctuary. Scientists like Deborah Kelly continue to monitor its fragile health. Expeditions with ROVs carefully document the slow changes over time. The ecosystem remains largely untouched by direct human interference. We must protect this pristine environment from future industrial exploitation. Its preservation ensures we can continue unraveling the secrets of life. It exists in a state of tranquil, ancient equilibrium. The lost city is the history of human exploration here is relatively brief. Yet each scientific mission has yielded profound oceanographic insights. The narrative begins in December of the year 2000. The research vessel Atlantis floated above the mid-Atlantic ridge. Scientists aboard were actually searching for ancient fault zones. They towed the Argo 2 camera system through the abyss. This fiber-optic vehicle transmitted live video to the surface. Geologist Deborah Kelly watched the monitors with careful attention. Gretchen Frew Green and Jeff Carson stood beside her in the dark. Suddenly, pale monolithic structures emerged from the deep oceanic gloom. They had accidentally discovered a completely unknown hydrothermal environment. The coordinates were 30 degrees north and 42 degrees west. The depth measured exactly. The team quickly deployed the human-occupied submersible named Alvin. 3 people squeezed into the titanium sphere for a closer look. They descended slowly into the cold Atlantic waters. Alvin glided past towering carbonate chimneys radiating an eerie glow. The pilots carefully maneuvered the sub near the fragile structures. Mechanical arms reached out to collect the first mineral samples. They recorded fluid temperatures hovering around 90 degrees Celsius. This was drastically cooler than the famous black smoke events. The initial samples revealed an incredibly high alkaline pH level. Values ranged from 9 to 11 across the active field. The scientists named this alien landscape the Lost City. They returned to the surface with unprecedented geological treasures. The Scientific in 2003, the vessel Atlantis returned to the site. This expedition focused entirely on mapping the massive carbonate towers. 32 dedicated researchers joined this comprehensive deep-sea survey. They utilized an advanced autonomous underwater vehicle named ABE. ABE flew in precise grids over the rugged underwater terrain. It captured thousands of high-resolution photographs of the chimneys. Sonar instruments bounced acoustic waves off the limestone spires. This created the first detailed topographical map of the region. Researchers identified the Poseidon edifice as the largest structure. It stood an impressive 60 meters above the seafloor. Alvin completed 19 separate dives during this intensive cruise. Scientists collected over 200 distinct fluid and rock samples. They utilized specially designed 2 years later, another major expedition sailed to the coordinates. The NOAA ship Ronald H. Brown arrived in 2005. Renowned oceanographer Robert Ballard led this particular research endeavor. His team brought the dual remotely operated vehicles Hercules and Argus. Argus hovered high above, providing powerful illumination from the darkness. Hercules worked carefully among the delicate white limestone pillars. This mission pioneered real-time telepresence technology for deep-sea research. High-definition video streams traveled through satellite uplinks to the mainland. Scientists sitting in shore-based command centers guided the underwater operations. They directed the ROV pilots to specific sampling locations. This allowed a global team to participate without leaving land. Hercules deployed delicate temperature probes into tiny chimney crevices. The sensors confirmed that William Brazelton led the microbial analysis of these precious samples. He discovered organisms surviving entirely on hydrogen and methane gas. John Barros studied the evolutionary implications of this extreme habitat. Their research required entirely new methods of DNA extraction. The biomass at Lost City was incredibly sparse but highly specialized. Standard laboratory protocols failed to isolate the delicate genetic material. Scientists developed gentle extraction techniques to preserve the fragile cells. They identified a completely new species of methane-producing archaea. These microbes thrived in the oxygen-depleted interior of the chimneys. The discovery pushed the known boundaries of life on Earth. Subsequent missions focused on long-term monitoring of the active vents. Researchers wanted to understand how the system changed over time. They designed specialized equipment. In 2018, another scientific voyage reached the site. The expedition utilized the highly capable ROV named Jason. Jason possessed advanced manipulative capabilities for precise scientific work. The pilots carefully placed microbial colonization chambers on the vents. These small titanium cylinders contained sterile mineral surfaces. They were left on the seafloor to gather biological data. Scientists hoped to see exactly how microbes settled on fresh rock. Jason also deployed long-term temperature loggers deep into the vents. These devices recorded thermal fluctuations over an entire calendar year. The data revealed an incredibly stable thermal environment. Temperatures rarely deviated more than 2 degrees from the baseline. This stability is completely unlike the volatile black smoker systems. The steady warmth provides technological breakthroughs continually enhance our understanding of this place. Early missions relied entirely on physical sampling and laboratory analysis. Modern expeditions utilize in-situ mass spectrometers attached to the ROVs. These instruments analyze the chemical composition of the water instantly. They detect trace amounts of organic carbon molecules in real time. This allows scientists to track fluid pathways through the rock. Acoustic Doppler current profilers measure the subtle ocean currents here. They map how the warm vent fluids mix with seawater. The alkaline plumes disperse slowly across the mid-ocean ridge. Chemical sensors track the shifting pH gradient as the water moves. High-resolution multibeam sonar continues to refine the regional bathymetry. We now know the exact volume of the massive carbonate deposits. The entire international collaboration is a hallmark of Lost City research. The British research vessel James Cook visited the area recently. European scientists brought their own specialized deep-sea monitoring equipment. They deployed autonomous benthic landers to measure carbon fluxes. These landers sink to the bottom and operate completely independently. They collect water samples at pre-programmed intervals over many months. Acoustic release mechanisms eventually detach the heavy ballast weights. The landers then float back to the surface for recovery. This provides a continuous chemical record of the hydrothermal activity. French researchers contributed advanced isotopic analysis techniques to the project. They studied the carbon-14 signatures of the limestone structures. This revealed the incredible age of the massive Poseidon pillar. The structure has been growing. Scientists also study the underlying geology of the Atlantis Massif. This underwater mountain hosts the entire Lost City hydrothermal field. Ocean drilling programs have extracted long-core samples from the rock. The drill ship George Resolution spent weeks positioned above the site. Heavy drill pipes penetrated deep into the exposed mantle rock. They retrieved cylindrical sections of solid peridotite and serpentinite. These rock cores act as a geological time machine. They show how seawater alters the deep crust over millennia. Mineralogist Susan Lang analyzed the organic compounds trapped inside the rocks. She found abiotic amino acids formed entirely without biological processes. This discovery revolutionized our understanding of deep Earth chemistry. It proved that life-building molecules can form in the dark. The drilling operation's future expeditions are already in the advanced planning stages. Scientists hope to deploy a permanent cabled observatory at the site. This would connect the hydrothermal field directly to the Internet. Fiber optic cables would stretch across the ocean floor to the vents. Continuous power would flow to a network of high-definition cameras. Sensors would stream chemical and temperature data 24 hours a day. Anyone in the world could watch the delicate chimneys grow. This ambitious project requires significant funding and engineering ingenuity. The corrosive nature of the alkaline water presents a major challenge. Engineers are testing new ceramic coatings for the underwater instruments. These coatings must resist the slow buildup of calcium carbonate. Without protection, the sensors would quickly become encased in limestone. Every new mission, researchers continue to analyze the fluid samples in shore-based laboratories. They use gas chromatography to measure the dissolved volatile compounds. The isotopic signatures of the hydrogen reveal its subterranean origins. It originates from the slow hydration of the mineral olivine. This chemical reaction is known to geologists as serpentinization. Scientists like Gretchen Frue-Green have dedicated their careers to this process. Her careful measurements quantified the exact rate of hydrogen production. The field produces enough energy to sustain a vast microbial biosphere. Yet the exact limits of this deep biosphere remain completely unknown. Expeditions continually push the boundaries of our oceanographic knowledge. We are only just beginning to understand the deep carbon cycle. The Lost City acts as a natural laboratory for these studies. It provides that the preservation of this pristine environment is a growing priority. Scientists advocate for the protection of the Atlantis Massif region. Deep-sea mining interests pose a potential threat to the delicate chimneys. Expedition data is crucial for establishing marine protected areas. Researchers present their findings to international maritime organizations. They argue that the scientific value far exceeds any mineral wealth. The biological and chemical discoveries here are truly irreplaceable. Future generations of scientists will need access to this undisturbed site. Long-term monitoring requires a stable and untouched geological environment. The acoustic landers must record the natural sounds of the deep. Industrial noise would ruin the delicate acoustic measurements. The scientific community stands united in defending the lost city. Their meticulous documentation let us reflect on the journey of a single water sample. It begins its life deep within the fractured mantle rock. It percolates upward, absorbing heat and undergoing complex chemical changes. It emerges from a porous white chimney at 90 degrees Celsius. A titanium syringe held by a robotic arm gently captures it. The sample ascends through the dark water column to the surface. It is carefully transferred to a sterile glass vial on board. Scientists freeze the vial to preserve the delicate chemical balance. Months later, it arrives at a university laboratory for intensive study. Mass spectrometers reveal the hidden traces of abiotic organic molecules. This single sample contributes to our understanding of the origins of life. It is a testament to the power of modern scientific exploration. The dedication of the research teams is truly inspiring. They work. The lost city stands apart from other global hydrothermal systems. Most known deep ocean vents are classic black smokers. These black smokers exist along active mid-ocean volcanic ridges. The East Pacific Rise hosts hundreds of these dark chimneys. They spew highly acidic fluids into the surrounding cold seawater. Temperatures at black smokers often exceed 400 degrees Celsius. Their structures consist primarily of dark iron and sulfur minerals. The lost city presents a completely different geological reality. It rests on the Atlantis Massif ocean core complex. This location sits 15 kilometers away from the spreading axis. Fluids here are highly alkaline with a pH around 11. This matches the alkalinity of household ammonia solutions. Temperatures remain relatively mild at 90 degrees Celsius. The chimneys form from white calcium carbonate instead of sulfides. Unlike black smokers, no underlying magma chamber drives this system. A chemical reaction called serpentinization generates the necessary heat. Seawater interacts with exposed mantle rocks called peridotite. This global anomaly fundamentally changes our understanding of ocean chemistry. Scientists have searched the global ocean for similar alkaline fields. The Stryton hydrothermal field in Iceland shares some minor traits. However, Stryton exists in shallow coastal waters near the surface. The Mariana Forearc contains some cool serpentinizing seafloor seeps. Yet none match the towering limestone monoliths of Lost City. It remains a singular masterpiece of deep ocean geology. This uniqueness makes the site incredibly valuable to science. The exact coordinates are 30 degrees north along the ridge. Most black smokers sit at depths exceeding 2,000 meters. The Lost City resides much shallower at 800 meters. This shallow depth directly affects the boiling point of fluids. Black smoker fluids often boil upon hitting the cold seawater. The alkaline fluids here never reach a rolling boiling state. The alkaline vents offer vital clues about the origin of life. Geochemist Michael Russell first proposed the alkaline hydrothermal vent theory. He suggested life began in porous rock structures like these. The Lost City perfectly models his theoretical ancient Earth environments. Early Earth oceans were warm, acidic, and rich in iron. The alkaline fluids from the vents create a natural gradient. This proton gradient spans across the thin mineral chimney walls. Modern biological cells use identical proton gradients for energy storage. The microscopic pores in the carbonate towers act as primitive cells. They concentrate organic molecules within their tiny protective limestone chambers. Serpentinization naturally produces abundant hydrogen gas and abiotic methane. These simple gases provide chemical energy for deep-sea microbes. Biologist William Martin expanded upon this origin of life hypothesis. He linked the geological gradients to early biochemical metabolic pathways. The last universal common ancestor likely thrived in such conditions. This theoretical organism is often called LUCA by genetic researchers. LUCA depended on hydrogen gas and carbon dioxide for survival. The Lost City provides exactly these elements in steady supply. Researchers study the methanogenic archaea living inside these white towers. These ancient microbes represent some of Earth's oldest living lineages. They survive without any energy from the distant surface sun. Their existence proves life can emerge from bare rock and water. Astrobiologists look closely at the Lost City hydrothermal field. They use it as an analog for other celestial bodies. Jupiter's moon Europa likely hides a vast liquid water ocean. Saturn's moon Enceladus also possesses a deep subsurface ocean. Both moons contain rocky cores that might undergo similar serpentinization. If alkaline vents exist there, alien life might also flourish. The white chimneys bridge the gap between geology and biology. They demonstrate how non-living chemistry transitions into living biological organisms. Scientists study the primitive RNA structures found within these microbes. Ribonucleic acid is essential for coding genetic biological instructions. The alkaline environment stabilizes these fragile early genetic molecular chains. Iron sulfide minerals within the chimney walls act as catalysts. They accelerate the synthesis. Of exploring this delicate environment requires exceptional technological precision and care. The Atlantis Massif rises sharply from the deep ocean floor. Navigating underwater vehicles around these steep cliffs is inherently dangerous. The primary Poseidon chimney towers 60 meters above the seabed. Its fragile carbonate flanges break easily upon minor physical contact. Researchers frequently use the submersible Alvin to visit the site. Alvin is a deep ocean research vessel operated by WHOI. Pilots must hover Alvin perfectly still in shifting ocean currents. Any sudden movement could destroy thousands of years of growth. Remotely operated vehicles face similar navigation and operational difficulties. The ROV Jason conducted extensive surveys of the white chimneys. Jason connects to the surface ship via a long tether. This tether can easily snag on the towering limestone spires. The depth of 800 meters creates immense hydrostatic pressure. Electronic components must withstand 80 atmospheres of crushing force. Collecting pristine fluid samples presents another massive engineering challenge. Standard titanium sampling bottles often contaminate the delicate alkaline fluids. Engineers designed specialized isobaric gas-tight samplers for this exact task. These devices maintain the extreme deep-sea pressure during ascent. This prevents dissolved hydrogen and methane gases from bubbling away. Scientists also struggle to sample the solid carbonate chimney structures. The rock is simultaneously brittle and surprisingly hard to cut. Robotic manipulator arms lack the tactile feedback of human hands. Operators rely entirely on high-definition cameras to guide tools. The darkness of the abyssal zone swallows all ambient light. Powerful halogen and LED arrays illuminate only a small radius. Beyond this artificial glow, absolute blackness dominates the underwater landscape. Mapping the field requires high-resolution multibeam sonar systems. Autonomous underwater vehicles like Sentry glide slowly above the vents. They generate detailed topographical maps of the entire hydrothermal complex. These maps help pilots plan safe routes among the towers. Researchers deploy autonomous temperature loggers inside the active vent pores. These titanium probes record thermal data for months at a time. Retrieving these small sensors requires pinpoint accuracy from the pilots. Acoustic transponders placed on the geological processes here concentrate unique and valuable chemical resources. Serpentinization creates high concentrations of rare earth elements nearby. These elements are crucial for modern electronics and renewable energy. Cobalt, nickel, and platinum group metals exist in surrounding crusts. However, the true wealth of the lost city is biological. The extreme environment forces microbes to evolve unique survival strategies. They produce specialized enzymes capable of functioning under high pressure. These biocatalysts hold immense potential for industrial and medical applications. Pharmaceutical companies constantly search for novel deep-sea genetic sequences. Compounds derived from vent bacteria might yield new antibiotic drugs. The methanogenic archaea could inspire highly efficient biofuel production methods. Their ability to process carbon dioxide is also heavily studied. Understanding this process might aid in global carbon capture technologies. Bioprospecting in the deep ocean is a rapidly growing field. The genetic blueprints of lost city microbes are heavily patented. This raises complex legal questions about ocean resource ownership. The area lies in international waters beyond any national jurisdiction. The International Seabed Authority manages these resources for global benefit. Yet regulations surrounding marine genetic resources remain somewhat ambiguous today. Scientists worry that commercial interests might outpace regulatory environmental frameworks. The delicate balance of the alkaline vents is easily disturbed. Even simple scientific sampling removes habitats that took centuries to form. The slow growth rate of the chimneys complicates any recovery. Calcium carbonate precipitates at merely a few centimeters per year. A single damaged spire might take a millennium to rebuild. Polymerase chain reactions in laboratories rely on heat-resistant enzymes. Deep-sea vent microbes naturally produce these incredibly durable proteins. Marine biotechnology depends heavily on finding these rare genetic sequences. The United Nations protecting the lost city has become a major global priority. Deep-sea mining poses the greatest threat to this ecosystem. Mining companies covet the mineral-rich crusts of the Atlantic. They seek to harvest polymetallic nodules and seafloor massive sulfides. While Lost City lacks sulfides, nearby areas are prime targets. Mining operations generate massive plumes of suspended sediment and dust. Deep ocean currents can carry these choking plumes for kilometers. This sediment could easily blanket the fragile white carbonate towers. The filter-feeding organisms living there would quickly suffocate. The unique microbial communities would lose their delicate chemical balance. Conservationists advocate for strict protection of the Atlantis Massif region. Many scientists propose designating it a UNESCO World Heritage Site. This would be the first such site in international waters. The area is already recognized as an biologically significant area. This designation highlights its crucial role in global ocean health. However, this title offers no binding legal protection against mining. The Mid-Atlantic Ridge ecosystem remains highly vulnerable to industrial exploitation. Researchers from the University of Washington lead conservation advocacy efforts. Oceanographer Deborah Kelly has spent decades studying this specific location. She emphasizes the irreplaceable nature of the alkaline vent system. There is no backup copy of the lost city on Earth. If destroyed, its ancient biological secrets vanish forever into darkness. The international community slowly works toward a high seas treaty. This treaty aims to establish marine protected areas beyond borders. The lost city serves as a flagship case for these discussions. Its otherworldly beauty captures the imagination of the global public. Documentaries and deep-sea live streams bring awareness to millions. People marvel at the ghostly white spires standing in darkness. This public interest puts pressure on policymakers to enact protections. Preserving this site means protecting our own evolutionary origin story. The silent towers continue to vent warm fluids into the cold. They have done so undisturbed for over 100,000 years. We must ensure they continue for another 100,000 years. The deep ocean requires our respect, patience, and careful stewardship. The International Union for Conservation of Nature monitors the situation. They publish guidelines for protecting vulnerable marine ecosystems from harm. The Lost City perfectly fits all criteria for absolute protection. Its biological diversity, the Lost City hydrothermal field, influences our global climate. This unique alkaline system actively alters local ocean chemistry. Seawater interacts with the exposed mantle rock far below. This specific geological process is known scientifically as serpentinization. Serpentinization absorbs significant amounts of dissolved oceanic carbon dioxide. The ocean acts as a massive global carbon sink. The lost dissolved carbon transforms into solid mineral structures down here. Calcium carbonate precipitates out of the warm hydrothermal fluid. This chemical reaction locks away atmospheric carbon permanently underwater. The towering white chimneys store this captured carbon safely. Scientists study this natural carbon sequestration process very closely. Geochemists measure the precise rate of deep mineral formation. These heat output from the Lost City is incredibly continuous. The venting fluids range from 40 to 90 degrees Celsius. This localized warmth affects deep ocean water density significantly. Warmer water rises slowly through the dark water column. This gentle upward movement contributes to global ocean circulation. Deep ocean currents transport heat across the entire globe. The lost cold Atlantic seawater surrounds the active alkaline hydrothermal vents. The ambient temperature remains near 4 degrees Celsius constantly. This stark thermal contrast drives local underwater water currents. Microscopic organisms ride these invisible thermal updrafts very safely. Nutrients disperse outward into the broader open Atlantic Ocean. The Atlantis Massif guides these deep underwater current flows. Oceanographers, the Atlantis Massif is a massive underwater mountain structure. It rises 4,000 meters above the surrounding seafloor. The Lost City sits near the summit of this mountain. The tectonic plates pull apart slowly in this specific region. This slow spreading exposes deep mantle rocks to cold seawater. The mineral olivine reacts strongly with the cold ocean water. This Dr. Deborah Kelly discovered this site in the year 2000. Her initial observations sparked decades of intense global scientific research. Researchers continuously return to 30 degrees 7 minutes north exactly. The exact longitude is 42 degrees 7 minutes west. These specific coordinates mark a scientific treasure in the deep Atlantic. Every expedition reveals new layers of hidden marine ecological complexity. The biologists question how life thrives without any warming sunlight. The metabolic pathways of these microbes remain largely unknown today. Archaea at the Lost City consume dissolved methane and hydrogen. These single-celled organisms exist independent of surface plant photosynthesis. Their survival mechanisms challenge our fundamental understanding of marine biology. Genetic sequencing reveals entirely new branches of deep microbial life. Scientists analyze. Dr. Gretchen Frugreen investigates the geochemical origins of early life. The Lost City mimics conditions of the very early Earth. Alkaline vents might have sheltered the first fragile biological cells. Porous carbonate rocks provide natural compartments for complex chemical reactions. These tiny chambers concentrate essential organic molecules closely together safely. Geothermal heat and mineral surfaces act as natural chemical catalysts. Life future research requires highly advanced underwater deep-sea exploration technology. Autonomous underwater vehicles will map the rugged terrain completely autonomously. These robotic explorers operate without direct surface human manual control. High-resolution sonar creates detailed three-dimensional maps of the dark seafloor. Scientists can study the delicate chimney structures without disturbing them physically. New chemical sensors detect trace elemental compounds in the deep water. These sensitive upcoming expeditions will utilize the famous oceanographic research vessel Atlantis. The remotely operated vehicle Jason will dive into the darkness again. Jason descends to depths of 800 meters very smoothly indeed. High-definition cameras capture the pale chimneys in absolute crushing darkness. Fiber optic cables transmit valuable data instantly to the ocean surface. Researchers on ships analyze the live video feeds in real time. Global sampling delicate carbonate structures requires extreme mechanical precision and care. Robotic manipulator arms use gentle suction devices for safe sample collection. These tools collect fragile microbial mats without causing any structural damage. Titanium syringes capture pristine hydrothermal fluid samples directly from active vents. Pressure-retaining samplers bring fluids to the surface completely intact and sealed. This prevents dissolved gases from escaping during the long upward ascent. Laboratory analysis scientists plan to install permanent seafloor observatories right here eventually. These stations will monitor the vents continuously for many long years. Acoustic modems will transmit data upward through the thick water column. Researchers will observe long-term changes in fluid temperatures very carefully indeed. Seismic sensors will detect tiny tectonic movements in the oceanic crust. This continuous data stream improves our deep geological understanding over time. The Lost Understanding the Lost City helps astrobiologists search for distant alien life. Similar hydrothermal systems might exist on distant icy solar system moons. Enceladus and Europa possess deep subsurface liquid saltwater extraterrestrial oceans. Serpentinization could generate essential thermal heat on these distant frozen worlds. Alkaline vents might support extraterrestrial microbial ecosystems in deep outer space. NASA studies the lost city as a perfect biological analog environment. The deep Atlantic, the towering carbonate chimneys are incredibly fragile and delicate geological structures. The tallest spire reaches 60 meters above the dark abyssal seafloor. This massive structure is named Poseidon by the global scientific community. A single physical impact could destroy centuries of slow mineral growth. The white rock is softer than typical oceanic basalt or continental granite. Calcium carbonate crumbles very easily under sudden external mechanical stress forces. These ancient conservationists advocate for strict legal protection of the lost city environment. The site qualifies as a highly vulnerable and unique marine protected area. International treaties must safeguard these unique alkaline hydrothermal vent fields permanently. Scientists share their data to support global marine environmental conservation policies. The United Nations considers special environmental designations for this specific site. Protecting the deep ocean preserves our essential global marine biological diversity. Future generations, the sheer existence of the lost city inspires profound and silent awe. White towers rise silently from the dark and seemingly barren ocean floor. Warm fluids shimmer visibly against the freezing cold Atlantic deep ocean water. Life finds a way in the most extreme and harsh environmental conditions. The resilience of these microscopic communities is truly and fundamentally remarkable. We learn deep humility by observing this hidden and quiet underwater realm. That the darkness of the deep sea is definitely not empty or lifeless. It is filled with unseen potential and quiet microscopic marine biological life. We project our scientific curiosity into this vast and pitch-black void. The deep ocean reflects our innate human desire to understand our existence. Every collected rock sample holds millions of years of hidden geological history. We are temporary respectful visitors in this ancient and silent underwater realm. The deep, you can visualize the pale chimneys clearly in your own quiet mind. Imagine the gentle upward flow of warm and soothing alkaline hydrothermal fluids. Picture the delicate white spires reaching up into the absolute pitch darkness. The deep ocean is a place of profound and absolute physical stillness. The heavy water pressure creates a comforting, secure, and very warm embrace. Time moves differently in the deep, dark depths of the Atlantic Ocean. The slow listen to the steady, slow, and calming rhythm of the deep currents. The ocean breathes slowly through these ancient and towering hydrothermal vent structures. The mechanical hum of the diving submersible begins to fade away completely. Your mind drifts alongside the microscopic and peaceful deep-sea marine biological life. The darkness of the water column is deeply and profoundly mentally calming. Shadows wrap gently around the towering white and silent carbonate mineral structures. The silence, the scientific instruments power down slowly for the long and quiet night. The bright lights of the robotic vehicle turn off completely and silently. Pitch blackness reclaims the lost city alkaline hydrothermal field once again tonight. The natural and original state of the deep sea is completely dark. The water temperature stabilizes near 4 degrees Celsius once again down here. The heavy deep currents rock the ocean floor very gently and slowly. Your breathing let go of the day as the vast and heavy ocean settles. The mysteries of the deep sea remain safely and quietly hidden away. The microbes continue their silent biological work in the dark ocean depths. The earth generates comforting heat deep within its rocky and ancient mantle. You are completely safe in this vast underwater and beautifully alien landscape. The pressure of the water dissolves your lingering daily stress and tension. The deep, the journey to the lost city is now finally and completely finished. We have explored the outer limits of marine biology and deep geology. The alkaline vents will continue their slow and steady natural mineral growth. Poseidon stands tall in the quiet Atlantic deep ocean darkness tonight forever. The deep sea rests in a state of eternal and profound peace. Your mind mirrors the absolute tranquility of the dark and silent ocean floor. Drift down, the darkness behind your eyelids matches the deep sea perfectly and completely. There is nothing left to analyze or understand here in the deep today. The scientific data is safely stored away for tomorrow morning to review. The natural wonders of the deep ocean will patiently wait for you. Allow the heavy deep silence to wash completely over your tired mind. The deep Atlantic embraces you in absolute, perfect, and deeply restorative calm. Rest now. The lost city remains a beacon of silent and profound underwater mystery. Its pale towers stand guard in the dark and quiet midnight zone. The deep ocean holds you in perfect, peaceful, and completely quiet isolation. Let the gentle deep currents carry you into deep and restful slumber. The journey ends right here in the quiet and dark ocean abyss. Thank you for watching our deep sea documentary tonight.